Okay, this video is about rational functions. Rational mean it look like a fractions. So your function look like a fraction. So to graph it by hand, we're going to need two things, which we need those two things for one of those things for many of the graph, including x and y intercepts. For rational function, because it looked like a fraction, it also add one more thing called asymptotes. Okay, and there are two sentences I want you to remember related to rational function. One is that the rational function is a function which means a function should pass what? It should always pass the vertical line test. And one more thing about rational function is that the graph is supposed to get very close to the asymptote. So when you abbreviate asymptote, please do ASY, okay? So the next one, we're gonna just like do the x and y intercept first, and then we can use a graphing calculator to graph it, because like your this class kind of allow you to do that. So one of the things you have to be careful is if you see something like that, make sure you factor the top and factor at the bottom, and hopefully you're still pretty good with the factoring. This one is kind of easier to factor because the leading coefficient is 1, so it's x, and 2 times 3 is 6. And I need the negative number bigger, so I'm going to say negative 3 and plus 2. And if you need to go through the AC method for factoring, please feel free to do it. But I will double check. X times x is x squared. 2 times negative 3 is negative 6. Outside we have minus 3x plus 2x is minus x, right? And the bottom is different of 2 squared, so it's x plus 1, x minus 1, right? We should always factor it first and make sure there's nothing we can reduce. And then we can find the x and y intercept, right? So remember, for x-intercept we set y equal to 0. So I'm just going to use the regular, the original one, which we have x squared minus x minus 6 over x squared minus 1. So first, like, I don't know if you remember, we did it earlier this semester. We need to multiply the LCD both sides to get rid of the denominator. So this got cancelled. 0 times anything is 0. So we have 0 equal to x squared minus x minus 6, which we just factor, right? Plus 2 minus 3. So x equal to negative 2, x equal to positive 3. So we got two x-intercept, including negative 2 comma 0, 3 comma 0. Those are my x-intercept, right? Okay, how about y-intercept? So for, in case you kind of confused with this part, we tried to get rid of denominator by multiplying LCD, which is x squared minus 1, to both sides. And again, anytime if you need to pause the video to write this down, feel free to do it. And y-intercept, we do what? We set x equal to 0. So we got y equal to, this is 0 squared minus 0 minus 6, 0 squared minus 1, right? So we got negative 6 on top, negative 1 at the bottom. Negative times negative is positive. So 6 over 1 is just y equal to 6, right? So my y-intercept is going to be 0, 6. Alright, so we got both my x and y-intercept, and they ask you to use your graphing calculator to graph. So let's try it. Second quit. Y equal to, I'm going to clear that. So I have a fraction here, right? Very important. Make sure the top part you put a parenthesis around it. So x squared minus x minus 6, close your parenthesis for the top part, divided by, bottom part is x squared minus 1. Close it, and then we can try to graph it, right? So sometime you may have to change the window, zoom in, zoom out, etc. But it looked like there's some gap here, right? So those are some kind of invisible line guiding the graph, and those are the asymptotes that we're going to talk about in just a little bit. So some of your homework may ask you to use calculator to graph and pick the y graph, and you will need to pick one kind of look like this guy. Okay. Alright, so this is that part, and then we're going to go to the next part, which talk about asymptotes. So on the exam, some of the question may ask you to find the asymptotes. And first of all, what is asymptote? So asymptotes is something guiding the graph. The graph will get very close to the asymptotes, and it guides the end behavior of your graph. Okay, so what are asymptotes? So they are lines, and usually they are invisible, in the space that a graph gets closer and closer to, but don't cross toward the end. Okay, so it guides the end behavior. Okay, so there are several types of asymptotes, including vertical, horizontal, and slant or oblique asymptote. And for some reason, most of the business book only focus on vertical and horizontal asymptotes, so we're not going to get into slant asymptote for this class. But if you do college algebra, they will also talk about slant or oblique asymptote. So first, we're going to look at vertical asymptotes. It helps you to decide how many pieces of graph you have. Okay, so it's very similar to finding the domain, which you will set the denominator equal to 0. Okay, this is trying to find the best spot of the graph. Like remember earlier we have this graph, so the vertical invisible line, vertical asymptote, is the part that the graph have to skip. So they call it the best spot of the graph. Okay, because it's a vertical line, your vertical asymptote answer has to be a x equal to some number. So that would represent a vertical line, right? X equal to a number, it calls the x-axis. Okay, let's look at the first one. We are only finding vertical asymptotes, okay? So they told you to set denominator equal to 0. So here only have that guy as denominator, right? If I set it equal to 0, then the vertical asymptote is going to be x equal to 0, right? So you only have one. If I sketch it real quick, it's basically white here, right? This invisible vertical dashed line is x equal to 0, which divide this graph into how many sections? It divides into 2 sections, one on the left, one on the right. So you have 2 pieces of graph with one vertical asymptote. Okay, one on the left, one on the right. This is the invisible vertical line that the graph don't touch, right? Okay, the second one, that looked like the one we just did earlier, right? So we already factored it, x minus 3, x plus 2 over x plus 1, x minus 1, right? So we did that earlier. And to find vertical asymptote, we set denominator equal to 0, right? So it's this part. And my vertical asymptote is going to be x plus 1 times x minus 1 equal to 0. So it means x equal to -1. Remember, it's x equal to a number, right? And then also x equal to +1. So make sure you have x equal to, okay? So I have two vertical asymptotes. If I sketch it real quick, one would be causing x equal to 1. One would be causing x equal to -1, right? So if you look at this graph, how many sections do we have? 1, 2, 3. So if we have 3 sections here, then we're going to end up with 3 pieces of graph. So when you have 2 vertical asymptotes, you have 1, 2, 3 pieces of graph, okay? Alright, so the last one is kind of like a special case. So we're not focusing on factor y here, so I'm going to factor this for you real quick. Top is difference of 2 square, x plus 3, x minus 3, and the bottom one, if you go through AC method, you will find x plus 7, x minus 3, because this multiplied together is -21, x times x is x squared. Outside is minus 3x plus 7x is plus 4x, right? So if we have that, do you see something special here? It looks like we can cancel it here, right? So this creates a little bit complications. First of all, I have one vertical asymptote. X plus 7 equal to 0, x equal to -7 is my vertical asymptote, okay? And then here, this is not a vertical asymptote because I cancel it. But if I set x minus 3 equal to 0, x equal to 3, right? So if you have this number, you plug it in here. 3 squared is 9, plus 4 times 3 is 12. It's 21 minus 21 will make the denominator equal to 0. So x still cannot equal to 3, even though it's not a vertical asymptote. It will become an open circle in the graph. Okay, so your graph still have to skip that even though you got canceled. So if I sketch you real quick, you will have x equal to -7 as a vertical asymptote. And then I don't know where 3 is going to land, but it's going to end up with some kind of open circle here for 3. Okay, but you have one section and other section, so you're going to end up with 2 pieces of graph. Okay, so we want to kind of like go over that so you have some idea. So this is for vertical asymptote. The main thing is make sure you always factor the top and the bottom, and set the denominator equal to 0. If something you cancel out, then that part is going to turn into an open circle, not a vertical asymptote. So this few examples just related to vertical asymptotes, okay? And make sure your vertical asymptote answer is x equal to some number. Alright, so the next one is going to be about horizontal asymptote. So horizontal asymptote, we use just one rule. It's called the highest power rule. So sometimes you may have the top and the bottom with the same power, or the top have lower power than the bottom, or the top have higher bottom power than the bottom. So how would the horizontal asymptote end up? So let me give you an example. Say if I have f of x equal to 4x squared plus 7, and then 3x squared plus 1. So another thing is horizontal asymptote is a horizontal line, so the answer has to be y equal to some numbers, okay? Y equal to some number is going to cause the y-axis, so it's going to be a horizontal line. Okay, looking at it here, we say highest power rule, right? So it's going to be just here, picking up the leading coefficient. So f of x is y equal to 4 over 3. This is my horizontal asymptote. So we kind of summarize it on the side, saying that if the degree of the leading term is the same top and bottom, then the horizontal asymptote will be y equal to the leading coefficient on top over the leading coefficient at the bottom. Okay, so that's the first type, and we basically apply the same rule for the next two, if you understand this correctly. Okay, so the next one, I'm going to give you another example saying that we have something lower on top, say x plus 5, and then we have 2x cubed plus x. Okay, so it looks like these have the highest power, right? So I am going to try to force them to have the same power. So how do I do that? This is x plus 5. So I don't have the term x cubed here, right? So if I put an x cubed here, that's not coming from the original question. I can multiply that with a 0 to get rid of it, right? So this is not changing the value. But now they have matching x cubed. And I can pick up the coefficient here. So this is y equal to 0 over 2, which is just y equal to 0, right? If you have 0 out of 2 cookies, mean you have 0, right? So they say if the degree of the leading term at the bottom is higher, like this situation, you will end up with your horizontal asymptote is y equal to 0. Okay? Hopefully that makes sense. It's just the same rule applied here. So the next one, apply the same rule. This time I need an example with the top have higher power. So say 6x to the 5th plus 1, this is x squared minus 2. So x to the 5th is the highest power, right? I don't have x to the 5th at the bottom. I can add that term multiply to 0, right? So the leading coefficient will be y equal to 6 over 0. I cannot have something out of 0, right? Or I cannot divide by 0, right? So this is going to be undefined. Okay, so if the top is higher, then you will end up with no horizontal asymptotes, all right? So just one rule, the highest power rule for this. Okay, very last, this does not really belong to here. So very last example here, you have one homework question kind of like that. So I want to kind of show you some example. They give you three functions, f of x, g of x, and h of x. And they want to know a few things. The first one say what is f of 1. So f of 1, basically you found your f function and plug in 1, right? So that's pretty straightforward, which is good. So use your f functions. Let's plug in 1 to it. So let me get some paper. If I have f of x is this, and I plug in 1 as my x, right? So basically I have put in 1 here, 1 here, 1 here. This is 0 times -1 times 4, right? So it just equal to 0. So for a, f of 1 equal to 0 is my answer. Are we okay? So the next one, the next question is saying that what is f of x equal to 0. So f of x now equal to 0. So this is A. Let's do B. 0 equal to x minus 1, x minus 2, x plus 3, right? So if you have 3 factor multiplied together equal to 0, you can set each of them equal to 0, right? X minus 1 equal to 0, x minus 2 equal to 0, x plus 3 equal to 0. And what would I get with that? You can solve for each one of them, move the 1 to the other side, x equal to 1, x equal to 2, x equal to -3. Are we okay with that? So that's B. C say they want you to verify g of -1 equal to g of 1 equal to g of -2 equal to 0. Okay, so they say if you plug in x equal to -1, x equal to 1, x equal to -2 to the g function, then it will end up with 0, meaning those three are your root or solutions or x-intercept. Okay, so the g function is x cubed plus 2x squared minus x minus 2. So why don't you pause the video and go ahead and try to plug these three numbers in here and see if you get a 0 out of all of them, okay? So take a minute. So I tried it on my own and all of them equal to 0. So we can say g of -1 equal to g of 1 equal to g of -2, all of them equal to 0. You verify it. Let's see. Okay, let's see. And if you need to pause the video, you can do that. How about D? D say based on the answer from C, what do you think is the factor form of g of x? So g of x, we basically say x equal to -1, x equal to 1, and x equal to -2, right? So if I put them back as factors, so these are zeros, so x-intercept, we can move the number back to the left. So adding 1 to here, x plus 1 equal to 0. And then minus 1 here, so x minus 1 equal to 0. And add a 2, so x plus 2 equal to 0. So we're doing the reverse steps. So those three are the factors of g of x, right? So I can just put them together. G of x equal to the first factor is x plus 1, second factor is x minus 1, and the last factor is x plus 2, right? So those are the factors for g of x. So that's for D. Okay, so how about E? E say, using the answer from D, which is here, what is the, oh, I did that already, sorry. So these are the factor, and E say factor form. So this is the factor form for the G function. Okay, so these are individual factor. If I multiply them together equal to g of x, that would be your factor form. Oh, sorry. So this is just the E say for h of x. For h of x, okay? So why are they related? So let's see. So that's not the same question. Sorry about that. So we just get the factor for g of x. So let's see the relationship between g of x and h of x. So g of x is x cubed plus 2x squared minus x minus 2, right? And h of x is 3x cubed plus 6x squared minus 3x minus 6. So they're kind of somehow related. Can you see the relationship between them? So look like I can factor out a 3 right here. So this is 3 times x cubed plus 2x squared minus x minus 2. So it looks like this is 3 times the g of x, basically h of x. And earlier we said the factor are what? This is x plus 1, x minus 1, x plus 2, right? So in other words, h of x is just 3 times these factors, right? X plus 1, x minus 1, and x plus 2, all right? So that's your E part. And the last part is what? Where did I put the question? Okay, so F. The F part say, basing on what you have learned in this exercise, fill in the blank. If f is a polynomial function and f of a equal to 0, then one factor of the polynomial would be, so this would be, this means x equal to a, right? So x minus a equal to 0. Okay, so remember, if you have a number in here, that means the x equal to the x-intercept equal to that, and then if we move the a back to the left hand side, this would be the factors. So for example, if you have f of 1 equal to 0, then it means x equal to 1 is the x-intercept, so this is a x-intercept, and then you can move the 1 back, x minus 1 equal to 0 would be one of the factors. So that's what they're trying to get across to you. Hopefully that will make sense. It's a lot of concept going on here. You may have to watch this a few times to get used to the idea. Alright, so we did something toward the end that they tried to go through the concept, like when you have a number, plug in x equal to 0, this is one of the factor, and then we go back and forth with these concepts, okay?